Welcome viewers, in this video we will see the solved problem based on the Thevenin's theorem contain AC circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Find the current through branch AB of the network shown below using the Thevenin's theorem. We need to find the current flowing through this terminal AB. Is connected with 5 ohm resistor. So here we contain the AC voltage source is there, 10 voltage with 0 degree. Here one 5 ohm is connected. Here 3 ohm and J4 resistor and inductor is connected. Here one more inductor available, J5. This load resistor 5 ohm. This treated as a terminal AB. Using Thevenin's theorem, we need to find what is the current flowing through the branch AB. The Thevenin theorem is we need to find the Thevenin equivalent circuit, that is V Thevenin connected in series with the Z Thevenin. V Thevenin is nothing but open circuit voltage, that is terminal AB is open circuited, that is this load resistance is removed and voltage across AB is calculated, that is nothing but V Thevenin. And Z Thevenin is nothing but voltage, the resistance or impedance across AB. By removing the voltage source, by removing the sources, either current or voltage source should be removed, and the impedance or resistance across AB is nothing but Z Thevenin. So this complicated circuit is simplified into one voltage source in series with the impedance. So thereafter, yes, this is AB, terminal AB, that is 5 ohm is there. So we can easily calculate the current flowing through this load terminal. Current I equal to V divided by Z Thevenin and ZL. So that is the important aim of the Thevenin's theorem. Complicated circuit is converted into simplified circuit. Now first step we will find the V Thevenin. Now we will find the V Thevenin, then we will go for R Thevenin. V Thevenin is nothing but disconnect Z equal to 5 ohm. The load terminal is disconnected. This terminal is disconnected. Right? So the voltage across AB is nothing but V Thevenin. We need to find what is the voltage across AB. So this will take, this is the loop. The current I is flowing through this loop. Right? So the voltage across AB is nothing but voltage across 3 ohm and J4 ohm. So by finding the current across this branch, we can easily calculate the voltage. V equal to 3 plus J4 into I. Right? So we are going to calculate current in the closed loop. So in the closed loop, what is that? Applied voltage, 10 voltage equal to voltage drop. So here 5 ohm is there, so 5 into I. Here 3 ohm is there, 3 into I plus J into 4 into I. Right? So according to KVL, Kirchhoff's voltage law, applied voltage equal to voltage drop. Voltage applied is 10 voltage with 0 degree, drop is 5 ohm into I, 3 ohm into I, J4 into I. So that 8I plus J4I equal to 10. So take I outside. So 8 plus J4 equal to 10. So that I equal to 10 with angle 0 divided by 8 plus J4. That is equal to 10 divided, this rectangular form can be converted into polar form. 8.944 with an angle 26.56. How to convert this? This magnitude is nothing but square root of 8 square plus 4 square. This angle is nothing but tan inverse 4 by 8. Directly using calculator also you can calculate. Otherwise using the formula you can calculate. Now we'll see the next step. So finally I equal to, after simplification, 1.18 with an angle minus 26.56 ampere. Right? So here the calculation is given. Square root of 8 square plus 4 square equal to 8.944. Tan inverse 4 by 8 equal to 26.56. Right. Now I is calculated. What is V Thevenin? I into the branch, what we discussed earlier, 3 plus 4J. The voltage across AB is equal to voltage across that branch. Both are connected in parallel. So I is 1.118 with angle minus 26.56 into this 3 plus 4J is converted into polar form. 5 angle 53.18. This 5 is nothing but square root of 3 square plus 4 square. This 53.18 is tan inverse 4 by 3. Right. Now we can multiply this 1.118 into 5, 5.59. These two angles multiplication mean we can add. This is minus 26.56, this is plus 53.18. So finally it is 26.56 voltage. Right. So this is the Thevenin voltage. 5.59 with an angle 26.56 voltage. So in the second step we will find the R Thevenin value by removing the voltage source. See here the voltage source is now removed. R Thevenin or Z Thevenin is nothing but the impedance across AB. We need to refer from this side onwards. We have to refer from this side, not from this side. Right. So Z equivalent or Z Thevenin or Z AB is nothing but we have to refer from this side. See this, the current is flowing through this inductor. At this point it is diverted. So this 5 ohm and 3 plus J4 ohm are connected in parallel. That is in series with the J5 ohm. Right. So the current is flowing from terminal A through this inductor. At this point diverted. That means these two branches are parallel. 3 plus 4J and 5 ohm are in parallel. That is connected in series with this J5 ohm. So that Z equivalent equal to J5 plus 5 into 3 plus 4J divided by 5 plus 3 plus 4J. That is R1 into R2 divided by Z1 into Z2 divided by Z1 plus Z2. Right. Now it is multiplied. 5J plus 15 plus 20J divided by 8 plus 4J. Right. So that is equal to 5J plus again this 4 is taken outside, here 5 also taken outside in order to simplify. Right. So finally it is 5J plus this 5 by 4 is 1.25. It is splitted. It is splitted into 3 plus 4J plus 2 plus J. In order to remove the J factor, it is multiplied by 2 minus J divided by 2 minus J. Complex conjugate of 2 plus J is 2 minus J divided by 2 minus J. So that we can remove the complex term available in the denominator. Right. Now we need to multiply these two. So multiplied by complex conjugate for further simplification. So 5J plus 1.25, 3 plus 4J into 2 minus J. This 2 minus J into 2 plus J is nothing but 2 square minus J square. A plus B into A minus B is nothing but A square minus B square. This J square value we know that it is minus 1. Already one minus is there. Minus of minus 1. And this term is multiplied. 3 into 2 6. 3 into J minus 3J. 4J into 2 8J. 4J into J minus 4J square. This J square also minus 1. So 5J plus 1.25, you have to add these two. 6 plus 5J minus 4 of minus 1 divided by 4 plus 1. 2 square is 4, 4 plus 1. Right. We'll go for further simplification. So 5J plus 1.25, 10 plus 5J divided by 5. See this, now the complex term is removed. So that we multiplied by complex conjugate. Right. So after simplification finally we have 5J plus 1.25 into 2 plus J. That is 5J plus, you have to multiply inside. 2.5 plus 1.25J. So final is 2.5 plus 6.25J. So the Z equivalent or Z Thevenin or Z AB is finally 2.5 plus 6.25J. Now we'll go to the next step. So the next step is draw the Thevenin equivalent circuit. V Thevenin in parallel with Z Thevenin with terminal AB, load terminal. V Thevenin we calculated 5.59 with angle 26.56 voltage. Z Thevenin just now we calculated 2.5 plus J 6.25. So 2.5 is resistor, 6.25 is inductor. Then the load terminal 5 ohm ZL terminal AB. Now the complicated circuit is simplified with V Thevenin connected in series with Z Thevenin with the load terminal. Now the load current can be easily calculated. I equal to V by R. V Thevenin divided by Z Thevenin plus ZL. So now it is simplified. V Thevenin is 5.59 with an angle 26.56. Z equivalent or Z Thevenin is 2.5 plus 6.25J. Then the load is 5. Now we need to add this. We need to go for further simplification. So 5.59 with an angle 26.56 divided by these two are added, 7.5 plus j 6.25. So 5.59 with an angle 26.56. This rectangular form is converted into polar form. Directly using calculator you can calculate, otherwise it is square root of 7.5 square plus 6.25 square, that is 9.76. The angle is tan inverse b by a, that is 6.25 divided by 7.5. b divided by a, that is 39.8 degree. Right? Now the rectangular is converted into polar form. So we can easily divide this. 5.59 divided by 9.76, that is 0.5725. The magnitude of the current is 0.5725. The angle divided means we have to subtract 26.56 minus 39.8, that is minus 13.24. Multiplication means we need to add the angle. Division means we have to subtract the angle. So finally we got the load current as 0.5725 with an angle of 13.24 ampere. So in this problem we solve the problem based on Thevenin's theorem. We calculated Thevenin equivalent circuit, V Thevenin in series with Z Thevenin. Then the load terminal is connected. So after simplified circuit we can easily calculate the load current. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.